Hello, my History 125 students. This is your Professor Donald Earl Collins. Um, and today is the first day of the first week of the course in technological transformations. And I want to get a few things over to you today about this week and next week's class, in the course, excuse me, in terms of themes and ideas and misnomers that we come to something like technological transformations with, as well as some of the videos I've already posted from my previous courses on facts and opinions and what to and general expectations and so on. So, just want to get right to it. Just hit a few common issues really quickly. Don't want this to be too long a video today. Probably the most important single thing to come away out of, especially for the first couple weeks, is that we are going to go through very quickly human history in terms of history, technology, and science to about the end of the medieval period, in basically a week, maybe 2 weeks. At the end of week two, we're done with the medieval period, where that puts us right around 1400 CE, 600 years ago. This is not a very good design in terms of the overall scope of this course. Yes, the bulk of technological transformation that's happened in the world has pretty much happened since about 1300 CE. A lot of that technological transformation has taken place as a result of European use of technologies and that spread of technologies from Europe to places like United States, the rest of the Western Hemisphere, eventually to Asia and other places. But because there's such a concentration on that, the most common misnomer is to only think technological transformation took place in Europe and then it spread to the rest of the world. When in point of fact, a lot of European advancement in terms of technology and science is built upon thousands of years of work that was done all over the world by people we would now call scientists. And all scientist means is who are seekers of knowledge. That's all scientist is. Um, it's kind of similar to the word student in that respect, right? But that's who, in an ideal sense, who a scientist is. Someone who seeks knowledge, seeks different ways of doing things. And so when you think about the totality of human history, the rise of Homo sapiens going back about 250,000 years, you think about the fact that all of them had to figure out how to eat, how to make their lives more comfortable, how to do things more efficiently so that they could survive, not just eke out a living, but eke out a better living than maybe the people who came before them, right? That's not always a linear process, which I'll talk about in a moment. But the reality is that um, many of the technological innovations that we credit to Europe and the United States or Canada or particular individuals weren't just individual achievements. These were folks who, might have built on work that other people, other groups had worked on over the course of 1,000 years, couple thousand years, maybe even tens of thousands of years. The whole agricultural revolution, for instance, is an example of that. Um, do not think that the first humans to think about growing food came from Turkey and Central Asia and what we would now call the Middle East. I'm pretty sure that human beings in China and human beings in northern India and Pakistan, people in sub-Saharan Africa and even Saharan Africa, probably all thought about the same idea at some point or other as in terms of just observing how plants grew. The reality is it took necessity, it took some climate change, non-man made in this case, to make that happen, right? And so, when you think about just that one example, what it took, knowledge of plants, knowledge of what kinds of grasses are edible for humans, which ones are poisonous or just non-edible, how frequently they grow, when do you plant them, all of that takes a lot of innovation, and you need people around for that. You need more than one person. One person doesn't sit there one day and just come up with the whole idea. It takes a lot of people a long time to build on those ideas in order to have a new process like agriculture to take place in various parts of the world over a 2 or 3,000 year period, which is exactly what happened, just as one example. Um, but all that's to say that when you think about when we finally get the week three, we start talking about things like maps and map making and cartography and so on. The European advancements of that, the scientific revolution that begins at the tail end of the Renaissance and so on, is building on work that had been done by um, Arab scholars, African scholars, Indian scholars, Chinese scholars, Greek scholars, Roman scholars, Persian scholars, Egyptian scholars, Sumerian scholars, over upwards of 5 to 10,000 years. And so it for the purposes of understanding context, if for no other reason, you need to understand these first couple of weeks that it's not just a bunch of Greeks and Romans sitting around coming up with new ideas. In point of fact, a lot of their ideas aren't new. They're not new at all. They're building on the old ideas. The Roman arch is a perfection of archwork that had been done by Egyptians upwards of 2,000 years before the Romans came up with their arch, just as one example. Greek columns were built upon 2 or 3,000 years of work done by Egyptians, done by Phoenicians, done by Sumerians, done by Persians in building long column temples, long column monuments going back to about 3,000, 3,500 BCE. The invention of the Greek alphabet, which is a major innovation, is not Greek at all. It's actually, part Egyptian, part Phoenician, part Persian. There are at least three cultures that contribute to the development of what we call the Greek alphabet, which is supposed to be the standard bearer of all writing systems around the world. Except it's not the only one. Chinese writing system's been around way longer than that. Just as another example. And in point of fact, the Chinese are the first to develop a printing press. Gutenberg's printing press might be a better printing press. It might be a more useful printing press considering you're only working with 26 letters. But it's not the original. Chinese came up with the idea for a printing press a good 600 years before Gutenberg came along and quote unquote invented his. And there's so many more examples of that. Gunpowder is another example. All kinds of examples of innovations that took place where Europeans picked up the mantle and build on it a lot faster. And that's to be sure. But it leads to a couple of other major points in terms of misnomers of understanding technological transformation, the history of technology and science and so on. And one of them is this: the idea that there's been this linear progression from the time first Homo sapiens walked the planet till now, that every idea built on the other one, and there's just been this progressive building block sort of thing. No setbacks, no decline, no loss of information or technology. It's just been this progression. Well, if that were the case, it says two things. It says, number one, Homo sapiens didn't come with the same. The first Homo sapiens had smaller brains than we have today. It's absolutely not true. We wouldn't be here. We wouldn't have survived. We would be extinct if those people didn't come up with the innovations they came up with. If they didn't know how to slaughter animals and gather nuts and live in groups and manage conflict and all the other things that we're supposedly able to do today on a much better scale, on a more civilized scale, they were doing 200,000 years ago. They didn't call it politics and economics back then, to be sure, but survival is all about people working together. And there were such fewer numbers of Homo sapiens that we're talking about that at any point they could have easily gone extinct. Without those people, we would not be here. And they couldn't have been the people they could have been without the basic human technological design from nature, from God, however you want to put it, of the advanced brains that we have, prefrontal cortex, having those lobes, having the lobes that we have, enables us to go into higher order thinking, to be able to imagine things, to be able to think ahead, to be able to innovate. but without other people being around to innovate with, there's only so much innovation that can take place within one generation. If you're barely making it to the age of 35 or 40, and there are only 140 of you living in groups, living in small groups that are fairly isolated. That's all. And if we lived in groups of 140 instead of groups of 10 million and 15 million in major metropolitan areas, it would be hard for us to, figure out how to cook. Forget about inventing apps. And I would dare say being able to control fire and cook is far more important than any app anyone could come up with for an iPhone or for a Samsung Galaxy S6. So just thinking through some of this, stuff around, innovating. You need people around in fairly large numbers to innovate. You need opportunity to innovate, and you need necessity. The agricultural revolution takes place because of climate change. Um, and even though some of us are of the opinion that climate change isn't man-made or that it doesn't even exist, there's plenty of scientific evidence to suggest that Earth has gone through many climate changes, some of which occurred when we were on the planet. One important one occurred around 77,000 BCE when a major volcano in Indonesia blew up, massive eruption that basically clouded the planet for about several years, but brought the temperatures down so low that it led to pretty much um, the partial collapse of Homo sapiens on the planet from about 20,000 people to maybe 2,000. And we're the descendants of those 2,000 people. So without, if they had if they are more primitive, if they didn't have the brains that they have in terms of size and complexity, they wouldn't have been able to survive that event. They just wouldn't have, their numbers would have been too small to survive it otherwise. That's one thing. But beyond just those survival skills is just a reality that technology does not just advance for the sake of advancement. It's not this linear progression. Well, we built the computer this generation. We're going to build some massive quantum computer the next generation. Well, we built rocket ships this generation. Next generation, we're going to have warp drive. We're able to split the atom this generation. We're going to have fusion reactors the next. So on. The pace of innovation has definitely picked up in the last 300 to 500 years, where you might have had a major innovation once every, century or so on. Then we've gone from once every century to once every generation to once every few years. But the level of innovation relative to the impact it has on people is pretty small. An app on an iPhone might be an innovation or invention, but overall, that's a much smaller impact than the invention of the personal computer from 1977, right? And that's a smaller impact than the invention of electronics from 1930s and 40s. And that's a smaller impact than the harnessing of electricity by Edison and Tesla in the 1880s and 1890s. And that's a smaller impact than the harnessing of steam power by a whole host of people in the 1700s, which is even smaller impact than the innovation of being able to circumnavigate the globe by Magellan and Zheng Han and a host of other people who managed to do it in the 15th and 16th centuries, which is a smaller impact than the advent of agriculture altogether, right? Without agriculture, there wouldn't have been large numbers of humans who even found cities in the first place, right? So you can talk about the pace of innovation and invention and technology picking up, but the reality is, without all those building blocks, we don't get anywhere. And those building blocks aren't linear. Plenty of agricultural societies failed. We're the byproduct of those whom succeeded, not the ones who failed, right? Even advanced classical civilizations with all the innovations of the Roman Empire, half of that empire collapsed. And the half that collapsed went into this long period where there was almost zero innovation in terms of technological development for literally 800 years. I mean, these people had to refigure out so much stuff. And a lot of their refiguring out wasn't refiguring out, they borrowed. They basically borrowed, and literally stole from the Arab caliphates, the Arab empires of northern Africa, Spain, and the Middle East, and northern South Asia, during the Crusades and other periods, they borrowed and stole and begged for a lot of innovation, technology, and knowledge to, to be able to, spin wool, to figure out how to use a Roman arch again, to build domes. I mean, and point of fact, the first successful dome built in Western Europe after the collapse of the Roman Empire wasn't even built until the 15th century. And so when you think about all of the different things that happened over the course of human history in terms of innovation, don't just think about, wow, this technology is great. This is a wonderful piece of technology. And don't just think high tech, and don't just think Europe, and certainly don't just think about the linear progression as if, there's this, humans just more, as if, I mean, the way I envision a lot of students thinking about this is sort of the way I thought about this when when I started studying history, I guess 30 or 35 years ago when I was, well, to be honest with you, when I was in middle school or high school. That sort of, you know, it's like you're filming this group of human beings from like 50,000 years ago, and they're just marching from one epic period to another epic period, from one era to one Enoch to one um, to another one, in which somehow you see them gradually develop from knuckle draggers all the way up to to the advanced civilized people that we are today. And that's hardly the case at all. What you should be looking at instead of looking at is that most human beings didn't make it past 40 until basically the 18th century. That's just a fact. It's the truth. Half, literally one half of all humans who lived on the planet died before they hit that age, and a goodly portion of them, 1 in 4, didn't make it past the age of 5 or 10. They died. They were stillborn, died from disease by the age of 2 or 5 or 10 before their immune systems even had time to develop. Simple as that. So you know that, and you realize that civilizations sometimes fail, sometimes rise, sometimes fall. That cities, of long ago, in Mayan city states, with literally hundreds of cities still covered up in jungle. Not to mention Harappa, India, in the Indus Valley region, and these cities that apparently held as many as 250,000 people at one point, buried under layer after layer of mud because of flooding over several thousand years, not to mention tropical rainforests or subtropical rainforests, as the case may be. So we assume so much that our society is basically built upon all these great and wonderful innovations, and they are, and it is. Our societies are, but they're not built on great and wonderful innovations just from individual greatness with brain power far greater than what humans had 2,000 or 10,000 years ago. It's the product of a combination of necessity and being around other people, and built on knowledge, but also built on knowledge and a lot of mistakes. A lot of mistakes, some of which we're paying for now. Um, in terms of climate change, in terms of complexities of our society, in terms of not always using, um, what's the word I'm looking for? Not using our scientific endeavors and technologies and innovations in the best sort of way. Unfortunately, a large portion of what we've been using our technology for has been to basically kill other people or maim other people, or in the interest of nationalism or in the interest of imperialism, but not necessarily in the interest of humanity as a whole. And there's so many examples of that, or in the interest of capitalism, as the case may be. So, just to reiterate, technology and innovation is not some progressive march of human history that everything just gets better and better generation after generation. It's not specifically a European thing. It's not something that only just happened in the last couple hundred years or last 1,000 years, but something that people have been building on over time. And to understand the technology, you have to understand the context from which it comes from. Without understanding that context, all we're doing is just marveling at a piece of technology when, some technologies, some really basic things that we still consider kind of important are the reason why we're still here today. The metal axe is kind of important, and metal axes have been around since the Egyptians have been used it as used copper axes to chop up limestone and build pyramids 3,000 years ago, right? I mean 5,000 years ago, excuse me, 3,000 BCE. So I would say that's probably a more important innovation than any app or any iPhone or any Samsung Galaxy X S6 or anything else you can come up with, right? And it begs this question beyond even the Jared Diamond article that I've already given you. It begs this simple question: when's the last time we've come up with a technology that's truly transformed our lives? I mean, at a fundamental level, it changes the way we live. And most of you are probably going to say iPhones, the personal computer, and so on. In some ways, sure, but does it fundamentally change the way you live? Has it changed your diet? Has it made you healthier? Has it given you 20 extra years on your life? Does it improve your quality of life to where your health is better and the way you eat is better and the air you breathe is better and the way you relate to other human beings is better? If you can't come up with an answer to that within immediately, it's okay, because there probably is a immediate answer to that. You would probably have to go back to the microwave oven to come up with a new technology that actually made life easier for people in a way that has been positive and mostly positive. So that said, one other thing I really want to get through quickly is it is very important that you watch the Facts and Opinions video that I did. Now, keep in mind, it's in a different context for another course that I did it for a couple years ago, but the ideas around that still apply. Evidence is important. Being able to back up what you have to say with evidence and examples, whether in discussion or whether for your term paper, is going to be important. It's probably the most important thing you'll have to learn this semester. Please refrain from, in my opinion, I believe, I feel kinds of statements and arguments in your discussions, in your responses to people's answers in discussion, and in your paper. I mean, to be honest with you, your opinion's not enough. It will never be enough. And some people think that opinions are unchallengeable, all opinions are equal. A, not all opinions are equal. And B, more importantly, any opinion can be challenged. Even when you have facts, even when you have an argument that's very cogent and very well put together, you can challenge that. An opinion is just some idea that you have based on what your parents might have told you, what you might have learned from church or temple or synagogue, or what you read in a newspaper article that was an op-ed piece that was done in the New York Times back in 2001 or something like that. It's not informed. Most opinions aren't well formed or informed. So I just implore you, I'm telling you this from the standpoint of an educator, not just from the standpoint of someone that thinks that my opinion is the only opinion that matters. My opinion might matter more, and it does matter more simply because my opinion's not an opinion. It's based on being a historian for a quarter century. So, it's based on that. But even then, you can still challenge me on evidence, on examples. And that's what I want to emphasize to you, to implore you not to be discouraged, not to be angered, not to be upset when I correct, when I say that you need to give me more than your opinion. We'll refrain from opinion-based statements. I'm asking you to do this so that you can learn, so that the course is useful to you, so that we're part of a dialogue where we at least agree on the examples and evidence. We might not interpret it the same way, we might not argue the same thing, but at least you're arguing off something, that is more than just something that you thought of 5 seconds ago. So that's it. Hopefully this will cover our first 2 weeks. So watch at your leisure, and thank you.